Hello everyone, let's start lecture 7. We will talk about charts. I'm your instructor, Ms. Laura Low. We are in week 3. In lecture 7, we will talk about how to do the visualization for data. And we will talk about distribution. In the previous lectures, we talked about how to create tables. Actually, each table, you can see they contain a data set. We create the table, and from the table display, it's very good visualization as well to see each column, the value for each column. But they still just a number or a string. So in this video, we will talk about how to put our table into a chart. So that will help us to do better visualization. The first thing, let's talk about attribute types. So the first you will ask, what are attributes? Attributes basically in the table, they are columns. So remember all the value in a column of a table, they always have the same type. And also, we didn't mention about that, they need to be comparable to each other in some ways. So in each column, use our NBA table, for example. In that table, we have different players. They have different position. They have different season. And they have different salary. So in the salary column, they are all the numbers, and also the value are in the money. And also in the salary, each value, they can comparable to each other. So we know some player, they have higher income. Some player maybe have a lower income. That's what we mean. They are the same data type, and also they can comparable to each other. So typically, we have two types of attributes. In other words, in the columns, mostly we see they are either numerical or categorical. So numerical is more easier to understand. We know each value is from a numerical scale. That means they are numbers. And sometimes they can be integers, sometimes they are full number. Numerical numbers or numerical measurements are ordered. We can say, you see, we know 1, 2, 3, 4. We know 2 is greater than 1, 5 is greater than 2. So that would mean they are in the order. So the differences are meaningful. Like earlier we said NBA player salary. Or we talk about in the survey, right? We say that every student take the survey. Some students take 8 hours. Some students sleep 8 hours. Some students sleep 4 hours. So those hours represent the sleep hour. So students sleep 9 hours is longer than the 8 hours. So the differences have their meaning. Then the second one is categorical data. So each value is from a fixed inventory. On the other hand, it's a fixed set they will choose from. Like our survey, we say we ask the students how many hours they sleep and also what their major is. So then you have a fixed inventory. Or in the NBA tables on player in different position. We have point guard, we have small guard, we have center. So they have specific position they can choose from. They may or may not have an order. Now sometimes those categorical data, they have an order. But a lot of time you see we didn't have an order. For example, center or forward or point guard or your major when we ask students to fill in their major. You are math major, computer science major, they are not really in the order. But at least the category, we know they are the data either the same or different. We know some players, they are play center. Some players, they play point guards. At least we know they are the two players, they are in the same position or different position. That's quite easy to understand the difference between numerical data and categorical data. Mostly you see the value, if they are numbers, we know they are the numerical data. Usually categorical, they are the string. But one thing we also need to be careful. Numerical attribute, just because the value are numbers, doesn't really mean the attribute is numerical. For example, the census data we just see last lecture, we have the column is the sex. So we have the value 0, 1, and 2. So we know the male represent 1, female represent 2. We make the data is easy to choose using 0, 1, 2. Of course, we still can use the string to represent male and the female. But sometimes, that's why we say sometimes even you see the value is numbers, but the meaning for the attribute doesn't really mean it's numerical. So we still need to see the exact meaning for that. So you can see here, we only have 0, 1, 2. We only have 0, 1, and 2 for the survey to choose one of that. So that's why they are categorical data. And on the other hand, you also can see it doesn't make sense to perform arithmetic on the categorical data, even they are numbered. For example, 0 plus 1 plus 2 divided by 3, that's meaningless because here the 0 actually means the total for the two categories. So the attribute for sex still is categorical, even though the number were used for the for the value. That's easier for us to process. But the column itself, they are categorical data. They are categorical attribute. So let's focus on numerical data. Okay, so numerical data, if we want to do the chart for that, usually we have two kinds. The first kind we call the line plot. So the line plot, they have a very important thing is they are consequential data. So you can see usually in your x-axis, they gradually increase. So we start from year 2000, 2002, 2004, 2006. So here we have in that year how many movies. So for the plot, for the line plot, because we will connect each dot, so they need to have the relationship according to the x-axis, the time or the distance, they gradually increasing. So we can see the pattern, how they change. So in here you can see from 2000 to 2008 or 2007, the number of movie they, according to the each year they increase the total number of the movie, but between 2007 to 2009 they drop. Afterward they pick up for a little bit. Also, that's the trend according to the time difference, how they affect the value for the one. And sometimes if your x-axis they not really have gradually change, or we didn't really want to see the pattern how they change. Sometimes we just want to see the location for those value how they reside. So then maybe you can use the scatter. So here you can see we have the number of the movies and the average for the here maybe the box office, the average for the per movie. So then you can see they are not really have a pattern, they will be increased or decreasing. But here at least we can see most movie actually they are between 20 to 50, and they are about the average between 50 to 150. So here's a comparison for the line plot and scatter plot. They both have two axes. You have x-axis and y-axis when you pass in the label name. So using the line plot is for sequential quantitative data. So for example, your x-axis have an order, so they are increased. And sequential differences in the y value are meaningful. And also they only have exact one y value for each x value. So usually because the x-axis is in order. So a lot of time we see they are according to the time. For example, earlier you see the years. So then they have the distance. So maybe we can say travel, how many distance, how they change. So using the scatter plots is for the non-sequential quantitative data. We are actually looking for association, how the x, y value they are related to each other. Let's see some demo to help you to understand better. Yeah, so from here we will continue using our census table. So the first thing, that's including all our library. Okay, so we read our data to create our census table. So the same thing, because remember the census table we have so many years. That still focus on only 2014 and 2019. Okay, so then we change the label name from the longer name to only 2014 and 2019. So then you can see the table like this. That's a table we create. The same table we create from last lecture. So you can see here according to the sex and age. So the population for 2014 and 2019. Yeah, so let's make, according to this table, let's make some line plots. Okay, so the first thing we want to see, of course, we want to see according to the age, how many population. So the first thing, we remove the total. Okay, so because 999 is the total for all the ages. So the first thing, let's remove the total. So we only have the age start from 0 to 100. So that's remove. So the simpler table, we will have the age, actually for the age under 999. So then just not working on the either male and female. We just see the total population according to the age. And also that's only used the 2019. Okay, so you can see from here we have new overall table. We just have the sex, we only choose for 0. So let's see the table first, then we show you the graph. Yeah, let me display the overall. Okay, so then you can see we only have the population, total population from age 0 to 100. Okay, then let's see how the plot is. So since you have 2014 and 2019, so we just see the population according to the 2019. So when you want to plot a chart, then you need to specify your x-axis column and your y-axis column. So we're using the age as our x. So then the population for 2019. Yeah, so that's our first chart. Okay, so you can see here your age start from 0. Okay, so we can see you say, oh yeah, of course it's not only 1, 2, 3, 4, 5. Actually, they are give you the easier to display. They have 6 0 afterward. So that means actually that's the 5 million. That's the million people here. Okay, so you can see, yeah, actually for between this one maybe is age 20 between age 25 to 30 we have the biggest population. So then over 60 we start dropping. But one thing you can see at the end for 100 they kind of pick up for a little bit. So be careful, this one is not only for the age 100. Since we don't have so many people over 100 years old, so we just make all the 100 years old people in 100. So that's why here they have much more. That's just because that's all the people over 100. Yeah, that's good. We have the x-axis age and the y-axis 2019. But also if you want to label your chart, you can also do that. You can either just put the comments or you can just print. Okay, or here we can put the title.